This is a brief demonstration of how you can control a DC motor with our Simulink platform. First, the hardware setup. Here we have our control board, which is connected to our PC running Matlab. Here we have our DC motor with embedded encoder, and our power supply. Our DC motor is connected to one of our H bridges, and our encoder is connected to one of our encoder inputs. Now let's go to Matlab. This is the Simulink model that we will use to control our DC motor. This encoder input block and this pulse output block are from our Simulink custom library. The rest of the blocks are from the standard Simulink libraries. This encoder input block is used to provide the measured angular position of the DC motor. The pulse output block is used to apply the control voltage to the motor. What we have here is the reference angular position, which is a square wave with an amplitude of 100 degrees and a frequency of 0.2 Hz. Here's our controller, which is a PID controller. The measured angular position is displayed in this display unit. It's also plotted in this scope along with the reference angular position. They will both be shown here. Now let's start it. First connect to the target, and then run the code. Now the yellow is the reference signal, while the pink is the measured angular position. And here's the actual motor's response. As you can see, the position of a DC motor is following the reference signal quite well. We have quite a good design. Overshoot is about 15% and settling time is about 1 second. Now let's change the controller gains to see what will happen to the response. Let's increase the proportional gain to 4 times the old value. Apply it. As you can see, the overshoot has almost disappeared. Now let's change the gain to 1/4 the original value. And apply it. And now we have about 50% overshoot and the settling time is quite high. So now let's stop it. And that's it.